Okay, so this video is looking at example 6. Example 6 has two problems that look at taking a polar equation and rewriting it as a rectangular equation. So we're trying to utilize some relationships between the polar and rectangular coordinate systems to get from this equation that is written in terms of r and cosine of theta and get it to be written in terms of x and y. So the first thing that I notice is that it's a fraction, and that's not maybe super helpful in this process. So I'm actually going to go ahead and multiply then 1 minus 2 cosine theta out to both sides. Okay, so in doing that, I clear the denominator on the right hand side, and then I end up with r times 1 minus 2 cosine theta equals 3. I can then go ahead and distribute that r, and that gives me r minus 2r cosine theta equals 3. And now I'm in a position to utilize an equation that will get rid of my r cosine theta, right? We know that our rectangular x can be defined as our polar r cosine theta. So here in this line where I have r minus 2r cosine theta, I can actually substitute that r cosine theta with x. So that gives me r minus 2x equals 3, okay? So at the very least, I've gotten rid of the cosine theta, right? And I've introduced x. So I'm on my way to getting into a rectangular equation. I now need to deal with r. And in thinking back to things that we've seen, we know that r is equal to the square root of x squared plus y squared, which can actually be manipulated into r squared equals x squared plus y squared, right? If I go ahead and square both sides, those are equivalent statements. So I want to maybe see if I can introduce an r squared in my equation so that I can make this substitution and have things in terms of x and y. Okay, so coming back over here to the equation that I was working on, I'm going to actually isolate r first. Okay, so I'm going to add over that 2x. That will leave me with r equals 3 plus 2x. Now, I have a couple options. I could go ahead and grab this equation right away, right? I can go ahead and say, hey, I have r all by itself. I can substitute in this x squared plus y squared. The square root of that is equal to 3 plus 2x. And now I have an equation in terms of x and y. We typically don't see equations written with that square root, so we can actually simplify this just a bit more. We can go ahead and square both sides and see that this is x squared plus y squared equals 3 plus 2x quantity squared. Now, either one is correct, right? The one that I have here or the one that I had before I squared, right? They're two equations in terms of x and y. But I wanted to take that step, that last step, because I wanted to show you that I could have actually utilized this equation, right? I could have actually squared both sides and then substituted in r squared. So I'm going to back up. I'm going to go ahead and actually erase this and show you an alternative way to deal with this. And you can kind of decide as you're working through this, as you're getting more and more comfortable with these ideas, which one works better for you, which makes more sense to you. So again, I could have here squared both sides and said r squared equals 3 plus 2x, that quantity squared, and then utilize this relationship that says r squared is x squared plus y squared, which would then be equal to 3 plus 2x squared. And you'll notice that that's the same answer that I got when I substituted r equals square root of x squared plus y squared, and then squared both sides. So notice that this is now an equation in terms of x and y, and since I was able to get to x and y from r and cosine, right, from my polar components, I know that I am done. I know that this is my final answer. So the x squared plus y squared equals 3 plus 2x quantity squared is my rectangular equation corresponding with the polar equation, r equals 3 over 1 minus 2 cosine theta. All right, we're going to go ahead and do one more example here on this video before you practice this idea on your own, and that is B, which says r is equal to sine 2 theta. So I want to remind you, we have a couple things that we can utilize here. We have the fact that x is equal to r cosine theta, and we have the fact that y is equal to r sine theta. Notice though that neither of those are sine, there's no 2 theta, right? That's not in the picture. So we're going to have to utilize a identity that we talked about in Unit 6, the double angle identity for sine, that tells me that sine 2 theta is the same thing as 2 sine theta cosine theta. Okay, so again, that substitution here in that first line is just the double angle identity for sine of 2 theta. Okay, and now all of a sudden I can utilize those two equations that I have in red off to the right hand side. I can say that r is now equal to 2y times x. Okay, and it's really, really tempting to stop here. The problem is that we still have this r. Okay, we need to get rid of r. Oops. Just realized I made a mistake. I got a little bit too ahead of myself. That doesn't actually work, right? We don't have that x is equal to cosine and y is equal to sine. We have that x is equal to r cosine and y is equal to r sine. So what actually happens is that these tell me that x over r is equal to just cosine theta, and y over r is equal to just sine theta. So what you'll notice is I took the r on the right hand side in each equation and I divided it over to isolate the cosine and the sine so that I can substitute here into this equation. Sorry about that. So instead of r to sine theta cosine theta, I have r equals 2 y over r times x over r. Okay, so we've introduced our x and we've introduced our y, but we need to deal with r. Okay, I think at this point it's easiest just to simplify a little bit to see that this is 2 xy, right, just multiplied those two together in the numerator over r squared. We can utilize the relationship that we saw in example A, the fact that r squared is the same thing as x squared plus y squared, and we can use the fact that r is the same thing as square root of x squared plus y squared. So we're going to go ahead and use those two equations to make a substitution that will take us out of equation in terms of r, x, and y, and it'll actually just all be in terms of x and y. So again, instead of r, I'm going to go ahead and write the square root of x squared plus y squared is equal to 2xy. And instead of r squared, I'm going to go ahead and write that that is x squared plus y squared. Okay. So technically, I do have an equation in terms of x and y, so I could be done. I think it's best just to go ahead and clean this up a little bit. If you square both sides, you can see that this is equivalent to x squared plus y squared equals the quantity 2xy over x squared plus y squared, all of that squared. And I think that's the version that is shown on your guided notes. Okay, but either way, squared or not squared, you've arrived at a final answer, right? You've arrived to an equation that is in terms of x and y. So at this point, I would go ahead and try questions 9, 10, and 11. Make sure that you're sending me an email or attending office hours this week to ask for any help or clarification on these topics.